Cool. Welcome all. My name is Dave Dustin. I am a principal engineer at Xero in the data reliability engineering space. Our focus is ensuring that the product teams, those are the devs and the people that actually build our products, are working with data in a sustainable and reliable fashion. Our primary database servers are SQL Server, and we have over 274 servers deployed with multiple databases in each of those servers. So making changes to databases is a really big thing with us, and we need to be able to do it because we have no maintenance windows at all. So today's session is breaking database changes without an outage. Right screen. There we go. So there we go. So there's this theory that modern systems need to be available 24/7. And if you have architected your system accordingly, that is possible. However, many systems were designed decades ago and did not take this into account because they didn't think either they would still be in business or that they would have the volume of traffic that they do, or that they would have rebuilt stuff by now and have built that resiliency in. With databases, many of the schema changes that we need to make often require extended outages, and many of these often also are being done for multiple teams. So multiple teams could be sharing a single database, and this is necessary to bring new functionality or to bring new features online. The session's about how we can change some of these without interrupting our customers. So today's agenda, some assumptions and common concepts, simple or incremental deploys, staged deploys. Now there's two types of these. We have very simple staged deploys and complex deploys. So the assumptions: source control is a source of truth. Everybody should be using source control. We should not be having stuff in a shared folder and stuff like that. We need to be able to see what was there previously in order to be able to reliably manage our environments. The ability to run scripts outside of a deploy. I hope that most people are using some sort of deploy pipeline, so continuous integration, continuous deployment, or even if you don't have that side of it, you have some tooling which you use to actually do your rollouts. You're not loading Management Studio and running a script. However, for many changes, you often need to be able to do that outside of the deploy process using Management Studio or preferably some auditable, controllable solution. Idempotent deploy scripts. If you accidentally run the same script again, you don't want it to make any additional changes. You want it to fail quick and easy without doing anything. Some sort of version deploy or log in your database. This is a really critical thing that helps you track changes over time. If you're not just making schema changes, but you're actually making data changes. So you have a control table that has a list of all of the records that you want to use for lists and stuff like that. Having some sort of version or deploy log in the actual database itself means that those deploy scripts can actually check that and say, I don't need to do this. The ability to compare databases. This is a critical one, especially if you're working in multiple environments where you have multiple instances of a database. Say you're running a sharded environment and you need to be able to deploy the same changes to multiple databases. The key thing is you need to know, are all my databases in sync? Do they match source control, or is there some anomaly somewhere, and why? Because you need to be able to compensate for that with your changes. Canaries. Canaries are a great concept if you have the ability to do so. If you have multiple application tiers and multiple database instances, I'm talking about federated or sharded databases, the ability to target a group of customers, so a group of app servers and a group of databases first before you roll out across the whole estate means that you can quickly and easily identify if everything is working as expected. And lastly, always plan in advance for rollback or preferably roll forward options, just in case something gets overlooked or something is awry. So the simple or incremental deploy. This is basically where we're rolling out a completely new object to the database, such as adding a new store procedure, view, table, column, etc. Or we're updating a view or procedure that doesn't change the signature. Now, what I mean by doesn't change the signature is we don't change the input parameters, their types, which ones are required, and the key thing is we don't change what is being output. So this could be that you make a modification to the store procedure so that if a certain value is passed through in a parameter, we now deliver a new result. But if that value isn't passed in that parameter, so you could have an options or a sort order or some sort of optional parameter that doesn't change it for existing versions of the application. So we roll out the object and then we deploy our application. So we don't need to take an outage because the two things are separate. The new version of the application will start using the new functionality and the code in the database will automatically be there and ready for it. Stage deployments. Sometimes this is called a blue-green deployment. Blue-green is more, in my mind, when you're actually swapping out whole servers. You're working with two different sets of servers or two different sets of databases. I'm talking about making changes within a database without needing to swap it out for a whole other A or B database. So we have existing applications talking to existing objects, tables, views, store procedures, functions, whatever. And we need to roll out a new version of that object. So there is a breaking change in this. So let's say we're adding some new parameters and they are required parameters, or we've changed what the output is going to look like, or we've changed what the structure of the view is going to be. So if we roll that out now, any existing applications will break. So what we do is we roll it out in parallel with the existing version of the object. So we'd say, get contacts. Now, what we're rolling out now is get contacts v2. Or some other naming system. Never use new or new version or dates or anything like that. Use something simple that you can easily track, sort of like a versioning. Now we deploy our updated version of the application. This is where canaries can come in really, really handy because you could have one application server has a new version of the application and it starts hitting that new version of the object. And if we find any faults, we can roll that application server back and it starts using the old version again. So once we've got that, we roll it out to all of the other application servers and we're good to go. Next step is we rename the old object. We don't delete it because there may still be a need for it, and we find that by waiting for the screams. If there are no screams, we can delete the object. Now, two types of complex deploys. We're going to add a new column to an existing table without negatively impacting the existing applications. So we add a new column as null or with the default. So with the default means that if it's a not nullable field, there is something there automatically. Working with SQL 2014 or later, that automatically puts it in, even though you don't need to go back and touch those existing rows, it automatically puts it in uses that default for existing rows. Now this can cause problems for applications that use select star or have a horrible ORM that doesn't properly check for columns. Basically it does a select star inside the ORM. So you need to work with your application developers to understand how their queries are actually working. We initiate a process of migrating the old content to the new column. So most commonly this would be something like an SSIS task or a process running inside a SQL agent that is just copying data between that old column and that new column, maybe making some changes or whatever is necessary. As we're rolling out that new change, we also institute triggers to populate any new or updated content. So if somebody modifies that old column, we also modify the new column at the same time. If somebody adds new rows, we copy the content from that old column into the new column. This is alongside the backflow stuff. Once it's all synced, we do the necessary changes we need to that new column. You could have added the indexes at the start, but sometimes that may cause problems. So we'll add them afterwards. We'll add constraints if it needs to become an F key. We could get blocking when we do the validation on that. Update any views or stored procs that are referencing the old column to use the new column, and we deploy the applications that are referencing the new column. And then once happy, we can drop the old column. Last one, the complex table. Now, the most common pattern for this one would be we have a table that are using integer. We need to go to big int. So what we're doing is we're going to deploy a new version of the table in parallel with the updated schema in it. So it's got a big int identity column. alongside the existing one. We create triggers on the old table, so anything new gets copied to the old table, to the new table as well. Again, we have a process to copy content from the old table to the new table. Once it's all synced, what we do is we create a view that looks like the old table with instead of triggers. So that means that if there's any writes to that table, they will automatically flow through into that view. It'll flow into the new table. Inside a transaction, we rename the old table to old table _ old, and we rename the view to what the old table used to be called. So contacts. Apps will use that view and not notice anything because that view is still using the old data type of int whatever. Now we deploy updated applications directly referencing that new table. So we're not hitting contacts, we're hitting contacts new, and it is big into where. Once happy, we can disable the view and then eventually drop that old table. Now I know that was a very rushed session and no demos, but yeah, I thank you very much for your time today.